In the previous video, we've learned how to sample data and make predictions using decision trees. Today, we will see how to use artificial neural networks to classify our data and evaluate their performance at prediction. Before we start, let's have an introduction to artificial neural networks. Artificial neural networks include a series of algorithms that try to mimic how our brains work. From neurology studies, we know that our brain is composed of a multitude of very simple cells called neurons. Neurons are connected to each other and form a network. They collaborate to let us perform our daily tasks. The artificial neural networks algorithms that we will analyze are supervised algorithms that requires a training phase and a target class for evaluation. The perceptron is the first artificial neural network that was introduced in 1958 by Frank Rosenblatt. Its main task was to classify images. As you can see, the perceptron structure is very simple. It includes an input layer and an output layer. Each layer is composed by simple elements that are called neurons, interconnected with all the neurons on the following layer. The structure of each neuron itself is very simple. Here is where all the computations happen. We have various elements in the neuron. First of all, we have the weights that are applied to the input data. The computation and adjustment of weights is what makes our artificial neural network able to recognize patterns in the data. It is also the most computationally intensive operation of the whole process. The adjustment of the weights happens during the training of the network. The next step is to make the weighted sum of the input data and pass it to the activation function. This function decides if the data just received is important for the task that our neuron is carrying out. The perceptron approach was good at classifying images, but has been found to be too simple to perform good in all the other tasks. Its natural evolution is a multi-layer perceptron. Introduced in the 1980s, this neural network has additional layers between the input and the output. This is the beginning of the deep learning era. The computations needed to train these networks were exceeding the computational power at the time, and only recently it has been possible to fully unleash its power. As you can see from the image, the layers between the input and the output are called hidden layers. The structure of the network is also called the network topology and describes the number of hidden layers and the number of neurons they contain. Remember, each of the hidden layers can contain a different number of neurons. The input layer will contain a number of neurons that match the size of the input, and the output layer will contain a number of neurons that match the number of classes that we want to use to model our data. Each output neuron will return the probability of the data to be classified in that class. Now, let's see how to implement an artificial neural network in Orange and do the predictions. Let's start to set up the workflow to classify our Titanic datasets. Let's load it using a file widget from the data panel. Select the Titanic clean dataset. Now we will add a Select Columns widget from the Transform panel. Connect it to the File widget. To start, let's use only the sex, age and p-class features and the usual survived as a target. We will come back to this in a while. Next step is to sample our data using a data sampler widget from the Transform panel. Connect it to the Select Column widget. Double-click on it. We will use again the fixed proportion of data sampling at 70%, like in previous videos. Now let's add a predictions widget from the Evaluate panel. Connect it to the data sampler. Now we should rewire the connection to the remaining data output by double-clicking on the link, rewiring, and then clicking OK. Now let's place on the canvas a neural network widget from the model panel. Let's connect it to the disassembler. Let's set the number of neurons in the hidden layer to 50 and regularization set to 0. We will keep the other parameters at the default values. We don't have to worry about the input and output layers, as they are automatically managed by Orange. We will use the neural network we just trained as predictor. Connect it to the neural network widget to the predictions widget. Now you can double-click on the predictions widget. Here you can see that our neural network achieved a precision of 84.9%, higher than the 84.4% we were able to achieve in the decision trees. Very good, but can it be improved? Let's try to add more data. Go back to the Select Columns panel and add Embarked as features. If you check the predictions now, you can find a bad surprise. The precision slightly dropped to 84.6% with a loss of 0.3%. Why? There is no single recipe with neural networks. Their inner working is not explainable. We don't have a way to visualize the decision like we did with decision trees. We may rely on experience and empirical tests. From our finding, we may have two considerations. First, some features is confusing the neural network, or second, the neural network is too small, it doesn't have enough power to model the data correctly. Let's try to increase the number of neurons of our neural network. To do this, double-click on Neural Network widget. Let's bring the number of neurons to 256. Close this window. After a brief retraining, we can check the results in the predictions panel. Oh, great! We improve our precision back to 84.9%. Okay, so bigger networks produce better results. Let's add another layer to the neural network. Double-click on the Neural Network widget, add a comma after the first number, and add 256 neurons. In the end, the neurons in the hidden layers field should read 256, 256. Close the window. The retraining takes a bit longer, as expected. Check the predictions panel and you will find out that our precision dropped to 84.4%. This network is too big for the quantity of data that we have. As you can see, to find the best network and make comparison between multiple approaches is a long trial and error process. In the next video, we will check how Orange can help us to compare different algorithms and neural network topologies using a more integrated approach. That's all for today. Ciao!